Here viewers, today I'm gonna show the configurable converter. At this part we will see this configurable converter with DAP converter, okay, with R load testing at the 1 kilowatt. Okay, so now I have connected the DAP converter as early part I have totally explained. Okay, all the connection I have made. Okay, and I have given the 323 volt as the input voltage of the bridge 1. Okay, at this time I have turned off the control. Okay, so 0 volt we have get at the output side of the DAP converter secondary, and the current is 0. Pulse is also turn off. Now I am turning on the control by pressing this button. Okay, so at this time the reference means the phase shift between the both converter, so the converter 1 and the converter 2 is 0. Okay, so I am turning on the system. Okay, so now you can just see the input voltage, the output voltage is gradually increased because we have applied the soft start. The current is also gradually increased, and also you can see the gate pulses of the bridge 1 and bridge 2. Okay, now I am applying the phase shift by pressing this button to transfer the power from primary to secondary. Okay, so at the 0 phase shift, the input voltage is 400 volt, then the output voltage is 34 volt. Okay, at the 12.7 ampere current. Okay, and here we have given the show the pulses. Okay, now by pressing this button we have increased the phase shift. Okay, so I am continuously increase till we have achieved the 50 volt at the output side. Okay, 400 volt here, and the output side is a 50 volt at 20 ampere current, and we have seen the phase shift between H1 and H3. Okay, means first switch of this bridge 1 and the first switch of the bridge 2. Okay, so I am continuously increasing, so you can just see the voltage and the current is continuously increased. Okay, and also you can see the phase shift is changing. Okay, so now you can just see I have applied the phase shift is 29. Okay, so you can just see at the 400 volt input we can get the 50 volt output at almost 19 ampere. Okay, so here you can just see the phase shift between the bridge 1 and bridge 2. Okay, clearly phase shift is visible. Okay, and here we have seen the power rating. So actual current, some error are there in the meter, so the input voltage is 400 volt. Okay, and power is 979 77. Okay, and the output voltage is 49, and the current is 19.8 ampere. So it is perfectly working with the open loop system with this R load. Okay, and the power is properly transferred from primary to secondary with the 400 volt input to 50 volt output at 20 ampere current. Okay, now just we will see the performance in the closed loop mode. Okay, so turn off. Also we have set the voltage is 423 volt like. Okay, and toggle into the closed loop. Reference voltage I have set is the 50 volt. Okay, and you can just see the output voltage is 0, current 0, and the pulse is 0. Now I am turning on the system, and it will try to adjust the output voltage as the 50 volt, and whatever duty it is adjust automatically. The same duty we have seen at the open loop mode. Okay, so we have verified it. So now turning on the system. Okay, so it is on. Okay, then you can just see the voltage, output voltage is increasing. So you can just see the phase shift is not applied. Now phase shift is applied. Okay, and it is try to maintain the power and the voltage. Okay, 1 kilowatt power and the output voltage is 50 volt. So you can just see the voltage. So it is now adjust to 50 volt. Okay, and here you can just see the phase shift between the bridge 1 and bridge 2. Okay, so here you can just see the 50 volt is maintained. Okay, at 19 ampere current. Okay, and now we can see. Okay, so reference voltage is 50, voltage input phase shift is 30. Okay, so in the open loop mode it is 29 and in the closed loop it is 30. So basically it is perfect. Okay, so power is 995 watt. Okay, output current is 20 ampere, voltage is also maintained 50, input voltage is 499 399, the current is 2.8 ampere. Okay, so basically the input power is 1.1080 watt and the output power is 990 something. Okay, so it is only the 90 watt power 60-70 watt power loss is there, but it is perfectly working. Okay, with the 1 kilowatt system. So here the 400 volt input, 50 volt output at 19 ampere current and the phase shift between the bridge 1 and bridge 2. Okay, also now we will see the current. Okay, so we have just removed the gate pulses and we have connected here the current. Okay, so now I have connected the current, primary current here. Okay, transformer primary current is here and the one gate pulses for the reference. Okay, so now you can just see the power is properly transferred 400 volt to 50 volt, 19 ampere, and you can just see these pulses is the H1 and the current, and this slanting is phase shift between the H1 and H2 we can clearly see here. Okay, also I am just zooming the waveform so you can clearly visible the current waveform. Okay, so likewise this DAP converter is perfectly working with the 1 kilowatt power in the open loop and the closed loop mode. Okay, thank you. In the later part we will connect at the output side we will connect the battery and we will see the DAP converter performance in the charging mode. Thank you.